So in this video, I'm going to do question 14 and 15 from task 23 in your packet. So for 14, we're looking at this figure and we are going to calculate the perimeter. And then for 15, we are going to calculate the area. Okay, so for the perimeter, it's the distance around the outside. And so we need to find all the outside pieces. Now, none of these we can just count because none of them are vertical or horizontal lines. So we are going to have to do a little bit of work to find all of these measurements. So if we start kind of with the triangles, what we can do is we can find the length of these segments by creating a right triangle and then doing the Pythagorean theorem. So this side, if we count it, is 1, this side is 2, and then if we call this side C to find it, we would do 1 squared plus 2 squared equals C squared. And then we get 1 plus 4 equals C squared. So we get 5 equals C squared. And then to solve this, we always take the square root. So we'd have the square root of 5 is equal to C. So this is square root of 5. And then you want to use symmetry. Okay, this other part of the triangle is going to be the same distance. It's, again, the height is 2 and the base is 1. So the hypotenuse would be the square root of 5. And E to F and F to G would also be the same thing, the square root of 5. Because again, if you made the triangle, it would be 1 and 2. So you don't need to like keep doing the Pythagorean theorem each time. Use the fact that you have congruent triangles to find this length of the sides. So let's do the other 2 line segments that we have, IH and AI. You can just do one of them. And again, they're going to be equal. So if I make my right triangle, I have 2, and then I have 1, 2, 3, 4, 5. And then to find this one, we're going to do A squared plus B squared equals, okay, C squared. I'm just going to call it X for something different so that we know that it's not the same value as our C here. So we get 4 plus 25 equals X squared. That's 29 equals X squared. And then we have the square root of 29. And so then A to I is also the square root of 29 because it's also 5 and 2. And we generally leave them as square roots. You can get them as a decimal if you want at the end, but for now we're going to be accurate and leave them as square roots. Okay, so then all the circles, we have half circles, and the distance around the outside is the circumference. So if I'm doing a half circle, we just do 1/2, and then the circumference formula, which is either pi d or 2 pi r. Either one is fine. So if I just use pi d, I'm going to find the diameter of these circles. So from G to H is my diameter, okay, because the other half of the circle would be here, and this would be the center of it. And that distance is 4 if you count it. And so the circumference would be 1/2 pi times 4. And then when you do this, you can just multiply the 1/2 by the 4, which is 2, and leave it as 2 pi. So this distance from G to H is 2 pi. And then A to B is also 2 pi, since again, the diameter is 4. And again, if you did 2 pi r, you would just get 2 times pi times 2, the radius, and that would also give you 4 pi, and then you would take half of it, which is 2. So then when we find the perimeter, we add all those distances together. So we would do like 2 pi plus, I'm going to work my way around. So I have square root of 5, square root of 5. I didn't do one part. Plus, okay, I have one more circle at the top that I need to do. So if I draw this diameter in, okay, I have 1, 2, 3, 4, 5, 6. So for this circle, this circumference, so let's just call this one C1 for circumference 1, and then C2 for circumference 2. I would do again 1/2 because it's only half the circle, pi, and then times d, which is 6. And then I do 1/2 times 6, which is 3 pi. So then I'm going to add 3 pi plus, keep going. So I have another square root of 5 plus a square root of 5 plus 2 pi plus the square root of 29 plus the square root of 29. Okay, and then I'm back to where I started 2 pi. So if you are leaving this, it's called like simplest radical form without getting it as a decimal, you can kind of combine your like terms. So the like terms are the ones that both have a pi in it. So we'd have 2 pi plus 3 pi plus 2 pi. It's like if you had an x, you just add the numbers that are in front, called the coefficient. So I have 2 plus 3, which is 5, plus 2, which is 7. So I have 7 pi plus. Then I'm going to find all my square root of 5. So I have this one, this one, this one, and this one. So there's 4 of them. What we really think is like there's a 1 in front of all of these. And so we're adding that number in front. So we're doing like 1 plus 1 plus 1 plus 1, which is 4. So it would be like 4 the square root of 5. Again, you can just count how many there are, and that's the number that goes in front. And then again, I have a square root of 29, and I have 2 of them. So again, you can either think of it as 1 and 1. So 1 plus 1 is 2, the square root of 29, or again, you can think there's 2, so I put 2 in front of it. So this would be my final answer without getting as a decimal. And then if you wanted to, you could type that in your calculator to get the decimal. So for that, if you have a TI, it would look like this. You would do 7, and then you would hit second, and then the pi key, which is here, plus, and then you would type 4, and then the square root. So second square root of 5, and then plus 2 second square root. Let me go back. So you have to make sure you arrow out, which I did not. So once I do 4 the square root of 5, I have to arrow over to get out of the square root. And then I'm going to hit plus 2 the square root of 29. Okay, you don't want it to be underneath, like the 2 and the 29 to be under the square root. So if that happens, that means you need to hit the arrow. Hit enter, and so we get 41.7 if I do 1 decimal place. Okay, so that's the perimeter. Then we're going to do the area. So the area is the total number of square units inside the figure. So we would need to divide this into shapes that we know. So I can do my half circle, and then a triangle, a half circle, a triangle, half circle. And then I can make this a big triangle, or you could cut it into 2 smaller ones, and then this a big rectangle, or you could cut it into smaller rectangles if you want. I'm going to find the area of each piece and then add them together. So the rectangle is the easiest. The area is length times width. So we count the length, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we multiply it by the width, 1, 2, 3, 4. And so we get that area is 40. So then we'll do the triangles. So this triangle and this triangle are equal. So we just kind of have to do the calculations once. For this triangle, CBD, we would do area equals 1/2, and then we do the base, which is B to D, which is 2. And then the height always goes from the base to the vertex on the other side. And so that's also 2. And then we do 1/2 times 2 times 2, which should give us 2. So this area is 2, and this area is 2. And that area is the entire triangle, not just this half piece. Okay. So then this triangle, we do the same thing. Okay. If I draw the height in, the height goes from the base to that vertex, which is 2. The base is, we said that length is 10. And so this area would be 1/2, 2 times 10. So 1/2 times 2 is 1, and 1 times 10 is 10. So this would be 10. And then we are going to find the area of the two circles. Okay, so just remember, this is the area, this is the height. I'll just erase that height because otherwise I wrote all the areas in. So then we're going to find the circle. So an area of a circle is pi r squared. If I want a half circle, we want half of it. So that means I do 1/2 pi r squared, or take pi r squared and divide it by 2. It's the same thing. So we need to find the radius. The radius goes from the center to one of the endpoints. So that would be 2. This one is the same. So I would do 1/2 pi and then 2 squared. So 2 squared is 4. And then I can multiply 4 and 1/2, which is 2. So I get 2 pi. This is 2 pi, and this is also 2 pi. Or you could consider like those together make an entire circle. And so if you want to do just pi r squared for that, you could, and you get 4 pi. And then I have to do this top circle again. So this radius goes from the center to this endpoint, which is 3. So we would do pi 3 squared, and we would have to do 1/2 of it because it's half a circle. So 3 squared is 9, and 9 times 1/2 is either 4.5 pi, or you can leave it as 9/2, either one. And then we're going to take the area and we're going to add them all together. So we have, I'll put the circles together. We have 3 circles, or 3 half circles, 2 pi, 2 pi, and 4.5 pi. And then I have the 3 triangles, which is 2, 2, and 10. And then I have the 40. Okay, and just make sure that you get all the pieces, that you don't forget something. So if we add this together, two plus 2 plus 4.5. So 2 plus 2 is 4, plus 4.5 is 8.5 pi, plus, and then I have 2 and 2 is 4, plus 10 is 14, plus 40 is 54. Okay, so that would be my final answer in simplest form. If I wanted as a decimal, I would do 8.5 times pi plus the 54. Okay, and we get 80.70. Okay, or 80.7. So that's how you do the area and the perimeter for this problem. Let me know if you have any questions.